Welcome to our deep dive into the life and work of James Clerk Maxwell.
Yes.
We're here because you're interested in learning more about this towering figure in the history of science, a man who revolutionized our understanding of electricity, magnetism, and light itself.
Absolutely.
To guide our exploration, we have some fascinating excerpts from Maxwell's biography on the McTutor History of Mathematics website.
Okay.
And get this, in school, he was nicknamed Dafty.
Dafty. Really?
Why on earth would a brilliant mind like his be called Dafty?
That's a good question.
We're going to find out.
Yeah, that nickname certainly piques the curiosity, doesn't it?
It does.
It's a hint that young Maxwell wasn't quite the typical student.
Not at all. He was born in Edinburgh in 1831, splitting his childhood between the bustling city and the family estate at Glenlair.
I see.
What strikes me is this constant curiosity that seems to be a thread throughout his life, even as a toddler. He was fascinated by how things worked.
Yeah?
Always wanting to know, as they say in the charming Scottish dialect, how it do.
That's a wonderful detail. It speaks to an innate desire to understand the workings of the world, a drive that would ultimately lead to his groundbreaking scientific discoveries.
It's as if he was born with the soul of a scientist. Sadly, his mother passed away when he was quite young.
Cool.
After a brief attempt at homeschooling, he ended up at the Edinburgh Academy.
I see.
And this is where things take an unexpected turn. He earns the nickname Dafty.
Okay.
Quite a contrast to the genius we know he became.
Yes. The descriptions from his school days are intriguing.
Yeah.
On one hand, he was seen as shy and even dull by some.
Really?
Yet he excelled academically, even winning prizes for his English verse.
Oh, wow.
So why Dafty?
Yeah.
It seems his classmates simply couldn't comprehend his fascination with complex diagrams and mechanical models.
So they mistook his deep thinking for dullness.
Precisely. They just didn't see the brilliance that was brewing beneath the surface.
Wow.
And that brilliance becomes evident early on.
Yeah.
At just 14, he writes his first scientific paper.
14?
On ovals.
That's remarkable.
Yes.
Most kids that age are worried about homework and video games,
Right.
not writing scientific papers.
Of course. And this wasn't simply child's play. In his paper, he went beyond the standard definition of an ellipse,
Okay.
which defines it as the locus of a point where the sum of distances from two fixed points remains constant.
Right.
He generalized this concept to include multiple fixed points with varying factors,
Yeah.
demonstrating a level of mathematical insight
Wow.
far beyond his years.
That's impressive. This generalization, it wasn't just some abstract mathematical curiosity, was it?
No, not at all.
Did it have implications for other geometric shapes or even for physics?
Absolutely. It foreshadowed a recurring theme in Maxwell's work. The ability to see beyond the specific to the general, to find unifying principles underlying seemingly disparate phenomena.
I see.
This kind of thinking would later allow him to connect electricity, magnetism, and light in ways no one had imagined before.
So even in this early work, we see glimpses of the scientific giant he would become.
Indeed. And his intellectual journey continues at the University of Edinburgh, where he becomes a favorite of the physics professor.
Okay.
What's really remarkable is that he's granted access to the lab to conduct original experiments as an undergraduate.
That seems incredibly unusual for the time.
It was.
What does that tell us about his potential?
It speaks volumes.
Wow.
This kind of opportunity was almost unheard of for an undergraduate student. Clearly, the faculty recognized his exceptional abilities and were eager to nurture his talent.
He wasn't just working in the lab, though, right?
No.
His reading list was astounding.
It was.
We see him borrowing works by some of the greatest mathematicians of the age. Cauchy, Fourier, Monge, Newton, Poisson.
He was clearly immersing himself in the cutting-edge mathematics and physics of his day, laying a foundation for his own groundbreaking work.
Then comes Cambridge, a whole new world of academic rigor and intellectual challenge.
Absolutely.
He initially chooses Peterhouse, but later switches to the legendary Trinity College.
Ah, Trinity. A true powerhouse of intellectual life in Britain at the time.
Yeah.
It was a hub for some of the most influential thinkers of the 19th century.
And his arrival is described as him arriving with immense knowledge, but in a state that appalled his very methodical tutor, William Hopkins.
Ah.
What was it about Maxwell that would have shocked his tutor?
From the descriptions, it seems Maxwell's mind didn't operate in a strictly linear, predictable fashion.
Okay.
He had this remarkable ability to leap between ideas, to see connections that others missed. This approach, while brilliant,
Yeah.
might have seemed chaotic to a more conventionally minded tutor like Hopkins.
This unconventional thinking is also evident in his performance
Right.
in the notoriously challenging Wrangler system at Cambridge.
Oh yes, the Wrangler.
For our listener who might not be familiar with this system, could you explain what it was and why it was such a big deal?
Certainly. The Wrangler system was a fiercely competitive ranking system for mathematics graduates at Cambridge.
Okay.
The top student was declared the senior Wrangler, followed by the second Wrangler, and so on.
Right.
To achieve a high ranking was a mark of exceptional mathematical ability.
I see.
And was highly prized.
And Maxwell achieved the rank of second Wrangler,
Yes, he did.
essentially tying for top honors.
Right.
Even though he didn't always conform to the rigid exam expectations.
Hmm.
What does that tell us about his intellect?
It shows he wasn't simply a master of rote learning or formulaic problem solving. He had a deep understanding of mathematical principles and could apply them in creative and insightful ways.
Whoa.
His mind was not confined by the conventional boundaries of the exam system.
But Cambridge wasn't just about academic competition. It was also a place where brilliant minds gathered and interacted.
Yes.
Did Maxwell, despite his shyness and
Right.
what were described as his eccentricities,
Mm-hmm.
find his place in this intellectual community?
He did, though, perhaps in his own unique way.
Mm-hmm.
He was known for his brilliance and for the unconventional way his mind worked. One account describes him as someone who would start so many hairs with his ideas,
Oh, really?
suggesting a mind that was constantly exploring, sparking new thoughts and connections.
A true intellectual whirlwind.
Yes, indeed.
So he finishes his degree at Cambridge, a proven mathematical talent.
Mm-hmm.
What happens next for this unconventional scholar?
He stays on at Cambridge, taking on pupils and winning a fellowship.
Oh, wow.
Another fiercely competitive achievement.
Yeah.
This marks the beginning of his professional career.
Okay.
And it's here that he begins to turn his attention towards the mysteries of electricity and magnetism.
Wow.
Yes.
So Maxwell is a fellow at Trinity, a rising star in the world of science.
Mm-hmm.
But his life takes a turn when his father falls ill, prompting a move back to Scotland
Right.
to be closer to him.
It's a poignant moment. He secures a professorship at Marischal College in Aberdeen just before his father passes away.
What a bittersweet time that must have been.
Yeah.
And amidst this personal upheaval, he tackles a scientific problem that had captivated him since his school days.
Mm-hmm.
The mystery of Saturn's rings.
Ah, yes. This was a puzzle that had stumped astronomers for centuries.
Really?
Why didn't those magnificent rings collapse under their own gravity or disperse into space?
Yeah.
What kept them so stable?
It sounds like a problem perfectly suited to Maxwell's unique way of thinking.
Absolutely.
A problem demanding both mathematical rigor and a touch of creative imagination.
I agree. And Maxwell rose to the challenge, submitting his analysis of Saturn's rings for the prestigious 1857 Adams Prize.
Wow.
There's a fascinating quote in his letters where he compares his work on the rings to the siege of Sebastopol.
Really?
A long and arduous battle requiring strategic thinking and perseverance.
That's a valid analogy. It gives us a glimpse into his mindset as he grappled with this complex problem.
Indeed. And his solution was nothing short of brilliant.
Okay.
He proposed that the rings were not solid structures, but were instead composed of countless small particles,
Oh, wow.
each orbiting Saturn independently.
So like a celestial swarm of tiny moons.
Precisely.
Yeah.
And this model, though radical at the time, perfectly explained the stability of the rings.
Wow.
It wouldn't be until over a century later, when the Voyager spacecraft sent back images of Saturn,
I see.
that Maxwell's theory was definitively confirmed.
Imagine that. A theoretical prediction from the 1850s, validated by space exploration in the late 20th century.
It's pretty amazing.
It's a testament to the power of his mathematical and physical intuition.
It's a remarkable example of how theoretical physics can anticipate and guide future discoveries. The Astronomer Royal George Airy was so impressed with Maxwell's work on Saturn's rings that he called it one of the most remarkable applications of mathematics to physics he'd ever seen.
High praise indeed. But Maxwell's intellectual curiosity didn't stop there. While in Aberdeen, he also delves into the study of color perception,
Oh, wow.
even receiving a letter from the physicist George Stokes, who praises him for establishing the 3 primary color perceptions on a numerical basis.
This might seem like common knowledge today, but at the time it was a significant contribution.
Really?
The prevailing understanding of color vision was quite different.
Okay.
Maxwell's work helped to lay the foundation for what we now know as the trichromatic theory of color vision.
Mm-hmm.
The idea that our perception of color is based on the stimulation of 3 types of color receptors in the eye,
Right.
sensitive to red, green, and blue light.
So he's making strides in astronomy color theory.
Yeah.
It's almost as if he can't resist diving into any scientific puzzle that catches his attention.
That's right. He was a curious mind.
But then comes another twist in his personal life. He marries Catherine Mary Dewar in 1859.
Okay.
But due to a college merger, ironically loses his professorship in Aberdeen despite being the principal's son-in-law.
He was the junior professor at Marischal College when it merged with King's College to form the University of Aberdeen.
Right.
And unfortunately, his position was deemed redundant.
What bad luck.
Mm-hmm.
He then sets his sights on a professorship at the University of Edinburgh, which seems like the perfect homecoming.
Mm-hmm.
But he's passed over in favor of his friend Peter Guthrie Tait.
This rejection is particularly interesting because the reasons given highlight a potential clash between Maxwell's unique teaching style and the expectations of the time.
Mm-hmm.
There were concerns about his ability to effectively teach large classes, particularly students who weren't as well prepared.
But we know from his students' accounts, like physicist John Ambrose Fleming, who described Maxwell's teaching as a delight for those who could follow,
Right.
and from praise by colleagues like Stokes, who lauded his singularly lucid explanations, that he was clearly capable of communicating complex ideas effectively.
It seems Maxwell's mind, which made such dazzling leaps in connections, might have been less suited to the traditional lecture format, where a more linear and methodical approach was expected.
Right.
He might have thrived in smaller, more intimate settings, where his rapid shifts in thought wouldn't leave students behind.
It's almost as if he was too brilliant for his own good, his ideas moving faster than some could keep up with.
I could see that.
So what happens to Maxwell after this setback in Edinburgh? Does he give up on academia?
Not at all. An exciting opportunity arises in London, a city quickly becoming a hotbed of scientific activity.
Oh.
He's offered the chair of natural philosophy at King's College, London.
London in the 1860s, a hub of innovation and scientific ferment. What an exciting time and place to be at the forefront of discovery.
Precisely. And this period marks a significant shift in Maxwell's career. Up until this point, he'd been primarily focused on theoretical work.
I see.
But at King's, he immerses himself in experimental research.
So he's not just formulating equations and building mathematical models anymore. He's getting his hands dirty in the lab, testing his ideas, and pushing the boundaries of what's possible.
Exactly.
Yeah.
But despite the thrill of experimental work, his life in London wasn't without its challenges.
Right.
He had a heavier teaching load than he did in Aberdeen.
Okay.
And he even gave evening lectures to working-class artisans. It shows his dedication to sharing knowledge and making science accessible to a wider audience.
It also reveals a different side of Maxwell, a man who wasn't just content with abstract theorizing, but who was also passionate about the practical applications of science and its potential to benefit society.
Absolutely. And it's during these busy years at King's that he makes one of his most groundbreaking contributions to physics, his work on the kinetic theory of gases.
Now, I'll admit, the phrase kinetic theory of gases sounds a bit intimidating. Can you break it down for us?
Of course. In essence, it's a way of understanding the behavior of gases in terms of the motion of their constituent particles.
Okay.
Instead of thinking of heat as some mysterious fluid that flows from hot objects to cold objects.
Right.
Maxwell, along with the physicist Ludwig Boltzmann, who independently arrived at similar conclusions, proposed that heat is simply a manifestation of the kinetic energy of these tiny invisible particles.
So it's all about movement. The faster these particles move, the hotter the gas.
Exactly. And this insight had profound implications.
Wow.
It challenged the prevailing view of thermodynamics and introduced a statistical element into the understanding of heat.
I see.
Temperatures weren't about absolute certainty, but about probabilities.
Okay.
The likelihood of molecules colliding and transferring energy.
So a hot object has a higher probability of transferring energy to a cold object because its molecules are on average moving faster and are more likely to bump into the slower moving molecules of the cold object.
You got it. It's a wonderfully elegant and intuitive way of thinking about heat transfer at a microscopic level. And this theory, now known as the Maxwell-Boltzmann distribution, is a cornerstone of statistical mechanics.
It's amazing to think that this revolutionary theory emerged from Maxwell's work during those demanding years at King's.
It is.
Alongside his experimental research and his commitment to teaching.
It's a testament to his intellectual breadth and his relentless curiosity. But perhaps the most astonishing discovery from this period comes from a seemingly simple calculation.
Okay.
Around 1862, Maxwell figures out that electromagnetic fields, those invisible forces that govern the interaction of electric charges and magnets,
Right.
propagate at roughly the speed of light.
Wait, so he's doing these calculations about these invisible fields, and the number he gets pops out as being pretty much the same as the speed of light. What went through his mind at that moment?
It must have been a moment of pure scientific epiphany. This calculation led him to a revolutionary conclusion. Light itself must be a form of electromagnetic wave.
Wow.
He was unifying two seemingly separate realms of physics,
Yeah.
the study of light and optics with the study of electricity and magnetism.
That's a mind-blowing realization. And this is before we even knew about radio waves or X-rays or any of the other forms of electromagnetic radiation that we now know exist.
Precisely. His work laid the foundation for our understanding of the entire electromagnetic spectrum, from the longest radio waves to the shortest gamma rays.
Wow.
It's hard to overstate the impact of this discovery on our modern world.
It's almost as if he opened a door to a whole new universe of possibilities, a universe that we're still exploring today. But this is just the beginning of Maxwell's remarkable journey. What happens next for this scientific trailblazer?
After those intense years in London, a yearning for a quieter life takes hold.
Okay.
In 1865, he decides to leave King's College and return to his Scottish estate, Glenlair.
So Maxwell returns to Glenlair seeking a respite from the whirlwind of London's scientific scene.
Oh.
But does this mean he retreats from the world of science altogether?
Not quite. While he relishes the peace and quiet of his estate, he doesn't completely abandon his academic pursuits. He makes occasional trips back to Cambridge, keeps up with the latest scientific developments, and even embarks on a rather unusual project.
Oh.
Editing the unpublished papers of Henry Cavendish.
Henry Cavendish.
An 18th century scientist whose work on electricity had been largely forgotten.
That's an interesting choice. It seems a bit out of character for someone like Maxwell, who was always pushing the boundaries of scientific knowledge.
Right.
Why would he dedicate so much time to the work of a scientist from a previous century?
It reveals a fascinating aspect of his personality.
Okay.
It suggests a deep respect for the history of science and a recognition that even older, overlooked work can hold valuable insights. He didn't just edit Cavendish's papers passively.
Right.
He repeated some of the experiments himself.
Oh, wow.
Meticulously hand-copying manuscripts and painstakingly analyzing the data.
It sounds like a labor of love driven by a desire to understand the nuances of Cavendish's work and ensure its proper place in the scientific record.
Exactly. But this quiet period of scholarly reflection is interrupted in 1871.
Okay.
When he receives an offer that's hard to refuse.
Oh.
He's invited to become the first Cavendish Professor of Physics at Cambridge, a newly created position with the responsibility of designing and setting up a world-class physics laboratory.
The Cavendish Laboratory. A name synonymous with groundbreaking scientific discoveries.
Indeed.
It's almost as if they created this position specifically for Maxwell, recognizing him as the leading light in the field.
It was a tremendous honor and a daunting challenge. He had to create a space that would foster cutting-edge research, attract the best minds, and ensure that Cambridge remained at the forefront of physics.
And how did he approach this challenge?
With his characteristic blend of brilliance and meticulousness, he poured his heart and soul into designing the laboratory, carefully selecting equipment, and ensuring that everything was just right.
Right.
And in 1874, the Cavendish Laboratory officially opened its doors, destined to become a hub of scientific innovation for generations to come.
It's a fitting legacy for a man who had dedicated his life to pushing the boundaries of physics. And it was during this time in 1873 that his most famous work, A Treatise on Electricity and Magnetism, is published. This is where his Maxwell's equations appear in their complete form.
Yes. These four elegant equations encapsulate the fundamental laws of electromagnetism, unifying electricity, magnetism, and light into a single theoretical framework. They're a testament to his genius and have had a profound impact on our understanding of the universe.
I have to admit, I'm not a physicist, so the mathematical intricacies of these equations are a bit beyond me. But I can appreciate the elegance and the power of what he achieved, bringing together these seemingly disparate forces into a unified theory.
Imagine the world before Maxwell. Electricity, magnetism, and light were seen as separate phenomena governed by different laws.
Right.
Maxwell's equations revealed the hidden connections, showing that they were all manifestations of a single fundamental force,
Wow.
the electromagnetic force.
It's a remarkable achievement, a true testament to the power of human intellect to unravel the mysteries of nature. But sadly, just a few years after the opening of the Cavendish Laboratory, Maxwell's health begins to decline.
Yes, in 1879 he falls ill. But despite the pain and weakness, he continues to lecture, driven by a passion for sharing his knowledge and inspiring the next generation of scientists. There are poignant accounts of him struggling to complete his lectures, his voice weakening,
Wow.
yet his mind still sharp and engaged.
It speaks to his incredible dedication to his work and his students. He wasn't just a brilliant mind, he was also a dedicated teacher and mentor.
Absolutely. And then on November 5th, 1879, one of the greatest scientific minds of all time passes away
Oh, wow.
at the relatively young age of 48. His doctor described his death as conscious and calm, a fitting end for a man who had lived a life of intellectual exploration and discovery.
What a remarkable journey. From a curious schoolboy nicknamed Dacty to a scientific revolutionary whose work laid the foundation for the modern world. His life is a testament to the power of curiosity, the thrill of intellectual pursuit, and the enduring impact of a truly brilliant mind.
His legacy extends far beyond the equations and theories he left behind.
He inspired generations of scientists and continues to shape our world in countless ways.
Let's talk about that impact. We've touched on it throughout our deep dive, but it's worth taking a moment to truly appreciate the extent to which Maxwell's work has shaped our modern lives.
Where do we even begin?
Yeah.
His discoveries about electromagnetism underpin so much of our modern technology.
Right.
Think about radio and television, broadcasting information across vast distances through electromagnetic waves. Think about radar,
Right.
used in navigation, aviation, and even weather forecasting.
Every time we turn on the radio, watch TV, or check the weather forecast, we're benefiting from Maxwell's insights. It's incredible.
And then there's the entire world of wireless communication,
Yeah.
mobile phones, Wi-Fi, Bluetooth. All of these technologies rely on the principles of electromagnetism that Maxwell so brilliantly elucidated.
It's hard to imagine our hyper-connected world without his discoveries.
And let's not forget about medical imaging.
MRI scanners, which use powerful magnetic fields and radio waves to create detailed images of the inside of the body, owe their existence to Maxwell's work.
So his work isn't just about abstract theories and equations.
Right.
It's about improving healthcare, saving lives.
Precisely. And his legacy extends even further. His insights into the nature of light and electromagnetism profoundly influenced Albert Einstein,
Oh, wow.
whose theories of special and general relativity revolutionized our understanding of space-time and gravity.
So Maxwell's work laid the groundwork for some of the most profound scientific discoveries of the 20th century. It's mind-boggling.
It's a beautiful example of how scientific knowledge builds upon itself, each generation standing on the shoulders of giants who came before.
I'm struck by the sheer scope of his impact. From everyday technologies to the most fundamental laws of physics, his fingerprints are everywhere.
It all goes back to that innate curiosity he displayed as a child, that desire to understand how it does. He never lost that sense of wonder,
Yeah.
that drive to unravel the mysteries of the universe.
And in doing so, he changed the world forever. We've only scratched the surface of his life and work in this deep dive, but I hope we've given you a sense of the brilliance and the lasting impact of this extraordinary scientist.
If our deep dive has sparked your curiosity, I encourage you to explore further. Read his work, delve into the history of his discoveries, and consider the questions he might be asking if he were alive today.
What scientific mysteries would he be tackling? What new frontiers would he be pushing?
Those are questions worth pondering. After all, as Maxwell himself once said, the important thing is not to stop questioning. Curiosity has its own reason for existing.
So keep that curiosity alive, keep asking questions, and who knows, maybe you'll be the next Maxwell unlocking the secrets of the universe.
Until then, happy exploring.